Our objective is to use the change of base theorem to simplify logs of other bases. So the change of base theorem, simply said, is a almost magical theorem that allows you to take any base that we're using in a problem and change it to our more common bases, like the common log or into the natural log. So what the change of base theorem says is if you've got log base A of C, so this would be some different base. It could be base 52, it could be base 4, whatever the base is. You can take the log of the number you're taking on the inside over the log of the base and get the same thing. So I'll use the common log for my, because that's typically what we use, because that's what we use the most on our calculators. So the log of C over the log of A will be the exact same value. So it doesn't have to be the common log, though. It could be, you could change it into any log. You could take the natural log of C and put it over the natural log of A. Or if you're very fond of, for instance, the log base, let's say 64, you could make it log base 64 of C over log base 64 of A. It's just any base. If you take the log of this one over the log of that one, it'll give you the exact same value. So let's see, some people really like this because it helps to simplify problems into just using only common logs and only natural logs rather than using every other base. So let's take a look at this first one here, log base 3 of 81. We can do that on some calculators. Some calculators have a log base key. Oftentimes it's found under the math menu. You have to go down a ways to find this base. So you can get this one and just put log base, and it allows you to put in a 3, and then you put in, on this one, put in an 81, and you get the answer. You can do it and get a 4 out. Now, that's okay. You might even be able to do this one in your head. 3 to what power equals 81? The answer to a log is the exponent after all. And so if that's the case, you get 4 out as an answer. Well, we can do this also if we need to. We can change this into the common log of 81 over the common log of 3, and then we can do that on any calculator, even the calculators that don't have that base key, the log base key under the math menu. Notice if I do this, if I do log of 81, close that, and divide it by log of 3, close that. Notice I get the same answer of 4. Changing the base works. Even if I wanted to change the base into natural log, notice if I use the natural log of 81, close that, divided by natural log of 3, gives me that same answer of 4. Or if I want to turn to my favorite base of 64, let's say if that's our favorite base, we could go math and go down to pick up the log base of 64, and then change that to an 81, and then get out of that one, divided by, and then go back to log. We got to keep that same base on both the numerator and denominator, log base of 64, and put into this one the 3, and I'm going to get the same answer of 4. You change it to any base. We will just commonly change it to the common log base, base 10, or the natural log. Let's look at this next one. This next one, if we want to simplify this or get evaluated, we do log of 70 over log of 3. Let's do that on our calculator. Okay, so log of 70 divided by log of 3, and that gives me a value of about 3.87. So approximately 3.87. Now that makes sense. It's a little less than this one. Instead of taking 81, 3 to what power would equal 70? Well, it's going to be more than 3, because 3 to the third is 27. It's not going to be 4. 3 to the fourth is equal to 81. It's going to be somewhere in between those two. All right, let's use it to solve this problem. Okay, to solve this problem, what we want to do is we want to first of all convert this one into a logarithm. So I'm going to use my circle tool. I'm going to go log base 13 of 23 is equal to 4x plus 2. Now what's nice about this is I can now find out what log base 13 of 23 is. So if I've got that, I'm gonna do a decimal estimate. You could do it exactly by just leaving it like that and doing your final answer. Let me start off by just getting a decimal estimate for it. So approximation. So I'm gonna do log of 23, and I'm gonna divide that by log of 13 to use the change of base theorem. And that gives me let's go out to 4 decimal places, 1.2224. 1.2224. And this is by doing log of 23 divided by log of 13, changing it into something that our calculator can handle. Now we're going to go ahead and solve this equation. So we're going to go ahead and subtract 2 from both sides. So I can go back to my calculator and subtract 2 from this, so minus 2, and I get negative 0.7776, negative 0.7776 equals 4x. Now I'm not rounding this one, so I can go ahead and divide both sides by the 4 to get rid of that. So divide this by 4, and I get an answer negative, let's round the final answer to 2 decimal places, negative 1.9 or negative 0.19. So negative 0.19 for an answer. Okay, now looking at that, if I wanted to just do an exact answer, what I could do is go back to this statement here. Notice I could subtract 2, so log of 23 divided by log of 13, and I could subtract 2 by subtracting both sides, and then dividing that by my 4 to get what the x is. By doing this process, I'm not rounding until the final answer. So let's take a look at that. I get log of 23 divided by log of 13. And then I'm going to subtract 2 from that, minus 2, and my parentheses, and then divide by 4. And notice I get that negative 0.19. Notice it's pretty close for, we've got the same decimal because we did a lot of keeping of the same numbers before we round it and avoided rounding errors. So the major idea here is whenever you see a log that doesn't have a familiar base. Let's say we have log of 43 of 217, and you want to figure out what that is, and you don't have the log base key on your calculator. All you have to do is do the common log of the 217 divided by the common log of the base, and that will give you your answer for this problem. Log of 217 divided by log of 43, and now I've got open all these different logs that I can do, approximately 1.43. I now have the world open to all these different bases that I can calculate what the logs are using the change of base theorem.